Now, let's say the output is floating, there is no load. In this situation, this transistor is not conducting, also this transistor is not working. So we have 12 volt in, some voltage drop over this transistor, this resistor, and the output is 5 volt. Now let's say we're putting a small load at the output. Small load, let's say 250 ohm. The current here will be about 20 milliamps. What happened? In this case, we want this transistor to conduct. Okay, this transistor we don't want to conduct, so we can hide it. Wait a minute. After that, we see how we are determine the values that we are talking about, 20 milliohm or so. So if here is 20 milliohm, it's also here 20 milliohms. Anything above 20 milliohm will go to this transistor and to the output. So this is the high output current. This transistor is the high output current. If this transistor, this is 790, even 80 is the same, can carry 1 amps of current, so we can deliver more than 1 amp of current. Now, what happens if we are making a bigger load at the output? Let's say 4 amps. 5 divided by 4, let's say 125 ohm. So the current here would be 4 amps. In this situation, this transistor is starting to conduct. We'll see after that how we determine these values. Okay. Now, when this transistor is conducting, the volt over this diode will be 0.7 volt, constant. So the output is heading at 4 amps. Why? We'll see after that. So this is like short circuit protection, because if we increase the load at the output, no matter how we can increase it, the volt over here will be the same, so the current here will be the same, so also the current that goes out will be the same, hence constant current. So even if we can short the output, the current will stay the same, because this diode is only that current at what we set it for 4 amps. The overcurrent will go on this transistor. So high output current, short circuit protection. What we have is CC, constant current, constant voltage, short circuit protection. Now let's talk about how we determine those values. Okay, when this transistor is conducting, we have also this diode over this resistor. The volt over here, when it conducts, it's 0.7 volt, constant. So the load over here, the current, will be 0.7 times 20 milliohm is 35 volt. We do 35 ohm. Because we want the current over 20 milliamps will be to go to this transistor, so this resistor value should be 35 ohm. Let's see again. 0.7 divided by 20 milliamps, 35 ohm. Now for the constant current, we want this transistor to conduct. In order to it to conduct, the volt over this diode should be, this emitter base diode should be 0.7 volt. So if we want for current 4 amps here, which is the same here, this transistor is also conducting. We need to take 0.7 volt, divide by this resistor, or by 4 amps. We get R 0.7, 1.175 ohm. So we can get some closest values. So this is a transistor high output current short circuit protection. These are the full formulas, and this is only a relatively calculation, not very accurate calculation, according the drops value, assumption of the drop value of those diodes. Thank you.